In problem 20, they have given us some data here that represents IQ scores for 26 randomly selected individuals. So that's this data here. And we want to construct a frequency distribution. That's a table using a class width of 10 and 70 as the lower class limit for the first class, and then construct a frequency histogram. So that's a bar graph of our data. So our lower limit here is 70, and then the class width is 10, so the next lower limit is going to be 80, and then 90, 100, 110, 120, etc. So that lower class limit comes in here. We want to add 10 to get to the next lower class limit. And then since these are whole numbers here, our upper class limits are going to be one less than the next lower class limit. So 79 is one less than 80, 89 is one less than 90, etc. All the way down to 130 to 139 because our highest value here, I believe, is the 132. And then we want to count the frequencies, or the number of values that are in each range. So 70 to 79, we count 1, 2 values there. And then 80 to 89, so count 1, 2, 3, 4. Looks like 4 in the 80s, and so on. You're just counting the number that are in each range there. And then the relative frequency bar graph, so we're going to start at 70 here. So 70 is the left-hand side of our first bar. And then you add the class width, so plus 10. So the lower limit of the next class is 80, and the lower limit of the next class, 90. So that way we're using nice round numbers here, 70, 80, 90, up to the lower limit of the class after this, if there was one, would be 140. And then our heights here are the frequency. So this is frequency on the vertical. And then this is IQ on the horizontal. So we've got a frequency of 2, so between 70 and 80, this is a bar of height 2. Frequency of 4, between 80 and 89, so 80 to 90, this is height 4, and so on. And we see here that we're getting a, fairly symmetric distribution here. It's a little bit higher on the left than it is on the right. That is our histogram.